show somebody they really do it, huh?
Walk them through what's going on. All right, well, okay, what Tony's doing, first of all, he's filling our reservoir up. While he's doing that, I'll go and give you an idea of what's going on here. Okay, this boat has already been loaded. We've got a bag on it. What you see here is our vacuum bag. When we pull a vacuum on this boat, we're getting a full 30 inches of mercury, or as close to that as we can get as a perfect vacuum. That's approximately 2.5 pounds per square inch on this boat, so it's a lot of pressure on this bag. It helps to hold the material together real tight. It helps hold our transom boards in there super tight. There's no voids in any of the glass. Once they open this thing up, what's happening here is we have a negative atmosphere under the bag. So when we open these clamps up and we allow the resin to go, the atmosphere that we're in right now is going to actually push the resin through under the bag. And it looks like we're sucking it through. In reality, it's a push, it's a gravity push is what it is.
How long does it take to infuse it?
This boat here will take about 15 minutes. We used to have them done a lot faster than that. We used to have a cord side that really moved resin fast. So we've taken the core out, and now we post-foam the boats in assembly. This is for that thump test, okay? So they run a little slower now, but we've the structure that's in these boats now, we don't even need to put a post-foam in there, but we do it just for the thump test, pretty much. So structurally, this boat is superior. We go to an ISO standard with a safety factor of, I think it's 1, and we're usually at the 2.5 range above the 1 safety factor. So these boats are solid.
So Dean, what is the bottom layout schedule of this boat?
Okay, the bottom laminate schedule on this one is obvious. We have a skin coat which is 90 mils. The skin coat is designed just to protect the gel coat. That's the whole reason it's in the boat. It's really not structural, although it adds structure. The next layer going to the bottom of this boat is going to be a 5608. The 5608 is a quad axis material. This means we have strands running the 0 to 90 in the plus and minus 45 direction. The 56 means it's 56 ounces per square yard is how we judge the weight of that material. Okay, the next layer on this boat here is going to be a layer of 108 ounce. It's a 090. It's called vector fusion, which means it flows resin real well all by itself. We don't have to put anything else in there to help that boat flow. I'll give you an example in a few minutes on the table over there what a surface flow media is like. This process here, we're using a variance between Bardem and VIP. We have an internal flow media in there, but it's just moving resin to the glass. The glass can move the resin the rest of the way.
These stringers that you have going port and starboard, do they get to infuse those secondary, or are those just...
No, those will go in after the bag is pulled off. Now we'll put them down in a bonding putty, and then we'll tape them in with a 2408.
So that's secondary.
Yeah.
We could bag them, we've done it, but filling the nooks and crannies of the bag becomes a little bit more time-consuming. Yeah. And so, you know, we're giving you all these acronyms. You're seeing a kind of a cool chemistry experiment going on here. So what does it mean to the end user? We go back to that performance. And to put it into perspective, everyone got in their bag these 2 laminate schedules. And what's interesting about this is Dean just racked off what's in the whole bottom of this boat. Okay, and I counted just the top of my head, there's about 170 something ounces of material on the bottom of this, in only a few layers. Most boat companies use a 24-ounce woven roving or 3610 woven type material, and they'll use multiple layers of that. The advantage here is we use 50% less resin in the product. So interestingly, this is the whole bottom of one of our larger boats. It's about what this is in an SBI process, okay? It has 50% more glass per square foot than the alternative in an open molded process. It looks a little thinner, okay, but you basically have 50% more glass. And this, I use the word peanut brittle, this is brittle. This is 3 times stronger if you put this on a braking test panel, as tested by Alcan, one of the big composite companies. What it does is it allows us to build a boat that is stronger, but also lighter. Now, our boat isn't just about light. Light is a kind of a curse. Stronger is what we're selling, but what it allows us to do is build a bigger boat. This is a 24-footer. Okay, it's a big 24 that performs better than a smaller 24-footer. It allows us to put more stuff in the boat, more seating, more options, and still get the performance. Where this all started was with the 31. When we went into the 31 market, we noticed that there was 2 markets. There was the contender market. They had a lightweight boat that performed very well with nothing on it. And then you had the pursuit regulator market, which had a lot of stuff on it, heavy, and had performance. So how can we have comfort and performance that we want, but also the comfort of features? The other thing about it, you may see it over here when you look at the materials, is that because we infuse the stringers in with it and the transom in with it, we are able to put more structural into the areas that are most likely to break or fail, where the outboard motors get placed. And as you can see here, things are starting to flow through. The resin is going in. This process, 35% resin. In this process, in the other open molding, it's about 65% resin if you're good. This is consistent every time. And one of these hulls weighs about the same every time. So that is the advantage. Now, obviously, we all can't talk to the retail customer about all the intricacies. Some are interested in it, some are not. But stronger, safer, better performance, and the differences are very real. And we've seen them out in the field as you look at the performance testing versus some of our key competitors. We are fortunate right now is that we're in a commodity business in some ways.
That's
it's very competitive. Product differentiation is hard to come by. We are fortunate that our main competitors are building boats in a very old-fashioned way, literally just shooting the resin and gel coat in, and whatever the weight is, the weight is. By offering this, and we think there's way more we can do with this, we think we have a competitive advantage. And it looks relatively simple to do, but a lot of boat builders have tried to go at this. There's a lot of knowledge that Dean and Daphne and Tony and the rest of our crew have on doing this. They're years behind. They could infuse the boat, but they couldn't do it apples to Christians. Many boat companies have tried, but then they have to double the price. The way we are doing it, the new laminate schedules, the single skin has made a big difference. It infuses slower, but the product is even stronger and better than it was. We'll continue to innovate. See that?
What resin are you using in the skin coat?
Okay, we are actually, this is kind of interesting. We use a vinyl ester blend in the skin coat, but we also put on these a barrier coat by CCP, and it's a, I think they call it a modified epoxy. Yeah, so it's a modified epoxy, and what's really advantageous about this, we went to this with the new laminate schedules. What's great about this, it's better than even a vinyl ester at blister protection. And that is a problem everyone's had. We've seen some in freshwater, but with this barrier protected, it also, for us, it helps on our cosmetics. One of the challenges here is cosmetics of infusion. And by using this barrier coat, we are able to help that.